Join us on an investigative journey as we educate each other on a scientific discovery, concept, or phenomenon.
Then we'll take a dive into the complicated and misleading world of pseudoscience to sort the factual from the fabricated.
I'm Matt McCabe.
And I'm Levi Bateman.
And this is Idio Facto.
What on earth are we going to talk about this week, Matt?
Wow.
We've just about run out of topics. Honestly, what on earth are we going to discuss?
We have definitely not nearly run out of topics, and your puns are terrible. And I hope you're ashamed of yourself.
Well, you probably know by now because you'd be listening to the episode and you could have read the title. But we're going to be talking about the Earth.
And you'll know a lot about your topic this week because you've actually researched it twice, right?
Yep. So computers require electricity to run.
Right. Yes. I was aware of that, actually.
Right, yeah. I would hope so. Some viewers... we don't have any viewers. Some listeners may not have been aware, so got to cover all bases. I was doing my research and taking notes as I normally would.
On a computer, which requires electricity.
Mm-hmm. And Christy was dusting cobwebs and things around the house and knocked the cover off of our circuit board. And it fell down and just happened to switch off the main circuit breaker for the house, for the entire house, as it was falling. So,
And as your computer requires electricity, and you are not prescient enough to have saved your work beforehand.
No, I wasn't saving, so it wasn't too dramatic, really. I lost about half an hour's worth of work, which isn't too bad.
Oh, okay. That's not how you explained it to me, but sure. If you just wanted sympathy, you should have just asked for it, okay?
I can get a lot done in half an hour.
Yeah,
and actually, I didn't give you a time frame, so...
No, you didn't.
If you assumed longer, that's on you, buddy.
Well, okay, fair enough. Sorry, it's my fault, really. I will no longer express concern for you.
Good, yep. You've learnt your lesson.
Bring us back down to Earth.
I will. I'll take you back right down beneath the crust, right down to the very plates that the crust sits on, the tectonic plates. So that's right, I'm talking about plate tectonics this week. So the word tectonic comes from the Latin tectonica, meaning pertaining to building, which makes sense, I suppose. They build the Earth's crust. This is what makes up what we stand on. We obviously haven't always known what tectonic plates were. It wasn't until this guy called Alfred Wegener sort of looked at a map of the Earth and noticed that the boundaries of certain continents almost looked like they would line up if you were to put them next to one another. And he proposed that they actually split apart. Somehow, he didn't know how. He proposed that there was this mega continent 200 million years ago, and he named it Pangaea. There's a couple of things that made him think this. Firstly, the shape of the land. He also noticed that fossils were similar at these continents that appeared to line up. Vegetation was often quite similar. Obviously, it had differentiated a lot since the split, but there were fossils of very similar species in both continents. So how could this happen if they weren't one and the same? And also, the geologies in the areas were usually quite similar as well. So he started to think maybe these areas were once joined. And this was... okay, that was Siri thinking that I was asking her. Okay, sorry. Silence.
Rookie.
I'm not talking to you, Siri. So this was in the early 20th century that he proposed this. And he didn't know how it happened. And really, no one actually took his idea seriously. He was just about laughed out of the scientific community, which is hilarious when you think about what we know now. But yeah, no one took him seriously. But he was the first guy, this Alfred Wegener was the first person to postulate that it was this continental drift that had occurred. He didn't know how it happened at that stage. And then in the 1950s, scientists were mapping this mid-ocean ridge that ran in a north-south direction in the Atlantic Ocean that we now know as the Mid-Atlantic Ridge. And they noticed one thing very interesting, that the further away that you got from the ridge, the older the seafloor was. There was a geologist named Harry Hess. He proposed that the seafloor was moving apart and that new seafloor was forming in the middle, which was forming this giant ridge, basically this mountain range in the middle of the ocean. So there's several other areas around the world that were similar to this, and this gave birth to the theory of plate tectonics. This was recent, like this was in the 60s that it was sort of accepted into the scientific world. And
right.
You think about how it's just common knowledge now, but it wasn't until sort of the mid-60s that it was accepted into the scientific world. And it was only 50 years before that Wegener was just about laughed out of the scientific community for proposing it.
Yeah, and it's funny because like volcanoes and earthquakes are not new phenomena, but we didn't have a plausible explanation for how they occurred until 50 years ago.
That's right. So it's amazing to think that we were flying planes before we knew about tectonic plates, that we knew how volcanoes and earthquakes worked. We'd just about gone to the moon alongside the discovery of these plate tectonics.
Yeah, that's incredible, isn't it?
The knowledge it's hard to comprehend for me that knowledge should line up, shouldn't it? But anyway.
Well, I guess it goes along with a lot of science over the course of history, in that we know more about the surface of Mars almost than we do about some areas of the deep ocean on Earth.
Yeah,
so,
that's right.
I mean, it's just by virtue of how much money has been pumped into those scientific endeavours and how many people have been interested in it. And sometimes it's just a matter of nobody's had a brilliant idea, or a brilliant idea that's been taken seriously.
Yeah.
Just out of the fact that they've been interested in other things. Einstein, if he wasn't interested in, physics, maybe he would have been more interested in biology and come up with a different theory of evolution, or Darwin was interested in physics instead of biology. You know what I mean? Like it's just it's just the way that these things work, I guess.
Yeah, these discoveries don't discover themselves. It takes somebody with abstract thinking to actually come up with this theory.
That's right, and it depends on their whim really as to what they apply themselves to, but also the knowledge of how plate tectonics works. It was obviously not essential to our knowledge of getting men to the moon.
No, that's true.
They're not dependent on each other. Sure, there's probably some overlap now that we understand that, but they're not essential for the other to occur. Do you know what I mean?
Although, had we used GPS to get to the moon, then tectonic plate movement would have been very interesting. And I'll get to that a little bit more later on. So there's about 7 large plates and a lot of other smaller plates that make up this tectonic plate system. So the large plates are the African plate, the Antarctic, Eurasian, North American, South American, Pacific, and Indo-Australian plate. Although the Indo-Australian plate in some places is divided into 2 plates, the Indian and the Australian plate. Yeah. And then there's about 60 other minor plates that are just very small, are either forming or are getting swallowed up by other bigger, more powerful plates. So tectonic plates are these large plates of the lithosphere, which is the rocky part of the surface of the Earth, essentially the crust. And they move around the outside of the Earth, and their movement is largely driven by these convection currents in the mantle. So the core of the Earth heats up the material that makes up the mantle, and that hot material rises to the surface of the Earth. It gets to the top, and then it cools, and then it moves along the surface of the Earth for some time, and then dips back towards the core. So it's this convection current. And if you can imagine a pot of soup on the stove, and the liquid beneath the surface is the mantle, and that crust that forms on the top is the lithosphere, are the tectonic plates. And they move around in the same way that this crust on the soup would move around. Except
the forces that we're talking about when it comes to tectonic plates are incomprehensibly huge compared to soup boiling on a stove.
Yeah, it was a handy comparison for people to visualize, but yeah, there's no comparison between a boiling pot of soup and tectonic plates.
Yes.
So yeah, as you said, this energy is phenomenal, but still, these plates move so slowly. Like, incomprehensibly slowly. And I think there was something that you said in a previous episode about how humans can't imagine speeds or anything outside of our own sort of ability.
It's Richard Dawkins' theory of the middle world. So
that's it.
Anything that's very small, we can't really comprehend. Anything that's very large, we can't comprehend. We live in this middle area where everything is human scale, human time scale, human physical scale, and it's very hard for us to understand anything bigger or smaller.
Yeah, and tectonic plates are so large and they move so incredibly slowly that we really can't picture it. And I've heard some people say that tectonic plates move at about the same rate as our fingernails grow, which is around about 100 millimeters per year. 10 centimeters per year, that's all they're moving. So it's really not a great deal at all.
Which is about a third of an inch for our Americans.
No, it's about 3.5 inches.
Eh? Oh, 10 centimeters.
Yeah.
That's what I meant.
Yep.
Yeah.
You got the old...
Not 1 centimeter.
The old 10, 100 mix-up.
How often do I do that? Nearly every episode I do
Classic. Don't build anything out of timber.
Yeah, no, right. No, it's fine. 100 meters squared, that's tiny.
So, you think that it's only moving 10 centimeters per year, but think about how far away Africa and America, the African continent and the American continent are. So, obviously the plates have been moving slowly but surely for hundreds of millions of years, which also is an incomprehensible amount of time.
Yeah, geological time is hard to get your head around, even just from an evolutionary standpoint. I obviously come from a biology background, so they call it deep time. So once you comprehend the depth of geological time, there's so much time for everything to happen. And it wasn't happening like sequentially either. Like evolution was happening alongside, the plates moving around and things like that. So
yeah, no, you're right. So there's something else very interesting that happens in mid-ocean ridges. So where two plates are moving apart, there's this phenomenon called magnetic striping. So what's happening here is as the plates are moving apart and magma, which is a largely iron-based rock, comes out of the Earth's mantle and forms part of the new plate, it's charged or it's polarized by the current polar field of the Earth. So where north is at the moment, all of the iron particles that's in that rock, as it spews out of the ground in the middle of the ocean, those iron particles will be aligned like a compass would to north. But if you actually measure the magnetism of the ocean floor out from the middle of this mid-ocean ridge, the magnetism actually changes. The polarity actually changes, which is one of the reasons how we know that the Earth's polar field, magnetic field, has actually changed throughout the course of the Earth's life, throughout history.
And we don't know why that happens, do we?
Not really, no. I know there's a few different theories, but it's not entirely understood.
It happens fairly regularly, doesn't it? Like it's a regular flip.
It does. It's actually happening at the moment. True north and magnetic north are something like 13 or 18 degrees different. So it's a massive difference on a map. And so if you're using a compass, you need to use magnetic north direction on a map rather than true north, because they're not the same thing anymore, and it's just getting more and more extreme. So there are two main types of plates. There are oceanic plates and continental plates. So the oceanic plates are thinner, but denser and heavier, and the continental plates are sort of lighter and fluffier, but much thicker. And where two plates meet is called a boundary. So there's three different types of boundaries, of plate boundaries. So there's the convergent, divergent, and transform boundaries. Now, divergent boundaries are often called constructive boundaries. These are the ones that I was speaking about before in the Mid-Atlantic ridge. They're moving apart. So that's why they're called constructive, because they're moving apart, more materials filling the gap, and it's building something, often a mountain. So magma spills up out of the mantle, usually, and a mid-ocean ridge is formed. This is when oceanic plates diverge. When continental plates diverge, we get a rift valley, like the Rift Valley in Africa, the Red Sea. These are both examples of a divergent boundary of continental plates. Then we get convergent or destructive boundaries. And they're called destructive boundaries because plates are often destroyed in the process in one way or another. So at a convergent boundary between an oceanic plate and a continental plate. The zone, the boundary, there's often a zone called a subduction zone. So what happens is that the denser oceanic plate will sink beneath the continental plate and it will get melted by the heat of the mantle. So it's often at these subduction zones where we see these deep ocean trenches and volcanoes. Can you think of any deep ocean trenches where there's a subduction zone?
Indonesia?
Yeah, well, so the Mariana Trench is right next to the Mariana Islands. And the Marianas Trench is the deepest place, the lowest point on the Earth's surface. And that's formed by a subduction zone. And then on the other side of it, we've got islands that were formed by volcanic activity. Another example of this is Japan. So on the eastern edge of Japan, there is a plate boundary. So there's a subduction zone, there's deep trenches, there's what's called a Japanese island arc. There's several islands. And the main islands of Japan were also formed by this subduction zone and this convergent boundary between two plates. Now, I was going to talk about volcanoes as well in this episode, but they'll probably have to get an episode of their own because they're super involved and super interesting, and I wouldn't have got any other research done if I'd been talking about volcanoes, so it'll have to wait, but I am excited about that one.
You didn't talk about transform boundaries.
Well, I'm about to.
Very good.
So the final boundary is a transform boundary. So these are boundaries where plates will slide past each other. When this happens, you get really bad earthquakes. So you can imagine these plates sliding, but the boundary between the two plates will catch. It won't move at a steady rate. It will catch. Tension and pressure builds up until eventually the tension is released, the plate jerks forward, and there's an enormous earthquake. You can probably think of a famous fault line or a transform boundary. There's one in America. It's called the San Andreas Fault, and it's off the Californian coastline. And this is the reason that places like San Francisco just get devastating earthquakes quite often.
Yeah, that's and the end of the world is going to happen on the San Andreas Fault because I watched a movie about that.
Is it?
Yeah, it's called
San Andreas?
Yeah, that's the one.
Cool.
Yep.
Well, that's terrifying.
Yep. End of the world, man. End of the world.
Well, there's probably another whole episode on earthquakes as well because they're pretty involved, or at least an Idio factoid.
So would I be right in saying that all earthquakes and volcanoes are a result of plate tectonic activity?
Yes, but not always at plate boundaries. So
right.
I'll probably go into depth in this more when I do the earthquake or the volcano episode, but you can get what's called hotspot volcanoes, and there's actually a hotspot volcano. If I looked out my window, I could see one right now because Mount Gambier was a hotspot volcano, and another extinct volcano just south of that, Mount Shank, is also a hotspot volcano. But you'll have to tune in to the volcano episode when we record that to hear more about that. And earthquakes are the same. There's no plate boundary that passes within Australia, but we still get earthquakes in Australia. And it's just within...
very mild ones comparatively.
Yeah, exactly right. So it's these sort of faults and just minor movement within the plate. Because as you can imagine, the entire plate is not going to move all at the exact same rate. They're huge and they move really slowly. So they are stretching and compressing at different points as well, which does cause earthquakes too.
I mean, I guess with anything that large, you've got a lot of inertia as well. So things don't want to move very easily. And it takes a lot of force to overcome that inertia. So.
Exactly, yeah. One side's pulling and stretching, the other side's pushing and compressing. And yeah, so you get all sorts of slinky plate action, I suppose.
Slinky plate action.
If you want to imagine that the plate's like
right.
Slinky. Yeah, I don't know. Yeah, you know.
That doesn't make any sense. Everyone ignore what Levi just said because that doesn't make any sense whatsoever.
No. Pull a slinky out from one end to the other.
Yeah. How is the Earth like a slinky? Everyone knows that the Earth is flat.
Hey, save that. I've got one more interesting point, and it's that my job is actually largely affected by tectonic plate movement, in a way. For my job, I make a lot of maps, and I use a program called a GIS program, which is geographical... which is Geographical Information System. So it uses geographical information, satellites, GPS points to build a picture of a map. Now we use this, what's called the GDA 94, which stands for the Geocentric Datum of Australia 1994, which is basically the coordinate system. So, point A lines up to point A on the map. Now what's happened, because the Australian plate, or the Indo-Australian plate, has moved north steadily since the first GDA was, since the last GDA was released in 1994, those points are now no longer all that accurate. So, as you can imagine, if they're moving up to 10 centimetres per year, remember, that's sort of the maximum. But even a few centimetres per year over 25 years is going to add up. So, it's no big deal for your iPhone GPS because it's still going to be relatively accurate. But for GPSs that I use at work that are sometimes down to an accuracy of 7 centimetres, we basically need that geocentric datum to be spot on. So there's the new GDA that's being introduced, which is the GDA 2020, which will be the new mapping system or the coordinate system that I'll have to use at work in my GIS program.
Cool.
Yeah.
Well, your GIS program's a lie, and I'll tell you why.
Why?
Well, you'll have to listen to my section to know what that's about.
Oh, okay. Come on. Bring on the music that separates two halves of the... All right, cue it now.
Okay, cueing it now. I'm doing the pseudoscience section this week, but usually what happens in this section is we take a topic that we already know to be pseudoscience, although we may not know much about, and then we prove it to be pseudoscience by using scientific evidence, right? Mm-hmm. But I came to a surprising conclusion this week upon investigating my issue.
What's that? The Earth is actually flat?
Well, the more I looked into it, the more I started to question, what if NASA is wrong? What if they are lying to us and the world isn't really a sphere?
This is not you coming out to me as a flat earther, is it?
I think everything I've ever known is wrong. What if we're just indoctrinated from a young age to think that the world is a sphere and then we never question it? Maybe the Earth might actually be a different shape entirely. Maybe it's not a sphere at all. I'm not kidding. I'm deadly serious. Maybe it's not a sphere. Wake up, sheeple. The Earth is not round. Technically, it's a bumpy oblate spheroid.
All right, yeah. That's a good... You had me worried for a second?
Yep. But for all practical purposes, we'll basically call it spherical. That's fine.
Yeah, cool. All right.
Now, of course, I am joking about that whole speech just then, but it's the kind of thing that you hear from flat earthers all the time. And conspiracy theorists in general. The more I looked into it, meaning the more YouTube videos I watched that use the same illogical arguments, the more I started to believe. So the theory of the flat earth is one of the topics that we get requested most, and until now I've been pretty hesitant to address it because it's also one of the most absurd.
But I'm so glad that you're covering it. I'm both very, very interested, but also I've been regretting this episode because flat earthers infuriate me so much, man. Honestly, it's interesting to hear their beliefs, but watching these videos of them passionately refuting science that is so well understood and demonstrable, we can demonstrate this. Anyway, you're going to get into all this, I'm sure. I'm definitely... In fact, I've even used the word demonstrable in my notes. I'm just going to sit over here and seethe, I swear to science.
Yeah.
This infuriates me.
So, all conspiracy theories, to a certain extent, present the same basic concept. They basically present an extremely vague alternative theory about a widely accepted fact with another vague explanation of why that would be covered up. And a lot of the power in these theories comes from the self-assuredness of the adherents to the conspiracy. The fact that they stick to their story despite overwhelming evidence to the contrary. And since most globe earthers don't have anything to prove, engaging in discussions with the kind of flat earth person is pretty pointless for them. I don't have to convince anybody that the earth is round because everyone takes that as a given. But flat earthers have a lot to prove. To that end, a major issue in scientific skepticism in general is knowing how much publicity to give to patently ridiculous minority beliefs that aren't based in any real science, because giving balanced time to both sides also gives the inaccurate impression that both sides have legitimate and equally justifiable arguments, right?
Yeah, I suppose so. I mean, this is also a tricky argument because you're then sort of getting into the point that the media, I suppose, controls what's true and what's real in the public eye.
Yeah. I mean, I think to counter that sort of thing, I'll start by saying that we've pretty much known that the Earth is a globe since the 6th century BC,
Right.
as in like 8,000 years ago. Plato wrote about it as a given in the 4th century BC, and by 330 BC, Aristotle had proved empirically that the Earth is a sphere.
Okay.
So for at least 2,000 years, 2,500 years, we have known, at least some cultures have known, that the Earth is spherical.
How did Aristotle do that back then? Without aircraft, without electronics even?
Oh, God, I was hoping you wouldn't ask me that. It's pretty complicated.
Yeah.
It's got to do with working out the angle of the sun from different points in the world.
Okay.
And like doing the trigonometry
Okay. Some
between those 2 points.
some complex mathematics.
Yes. Check the show notes, Levi, if you want to know more.
Okay.
So the number of people today who claim to believe that the Earth is flat is a tiny, tiny minority of the world's population. It's also hard to separate the people who genuinely believe that the Earth is flat from the people who are just joking about it. So getting a read on the actual number of true believers is pretty difficult. But suffice to say, it's some proportion, likely smaller than 1% of the population in modern Western society, and it's probably a lot lower in developing countries.
Yeah, okay.
Regardless of the number of people, they are extremely loud. And they have some high-profile bandwagoners like Shaquille O'Neal that add to that noise.
Really?
Loud, though, doesn't make you any less wrong.
No, yeah, absolutely.
And yes, really, there's a whole bunch of basketball players who claim to believe that the Earth is flat. Shaquille O'Neal, let's just say a bunch of basketball players are all in it together.
Wow. Okay.
So, in short, the flat Earth theory was repopularized by Samuel Rowbottom in an 1865 book called Zetetic Astronomy, Earth, Not a Globe.
That's a terrible name. Not Tectonic astrology. Rowbottom, yeah.
It's Rowbotham.
Oh,
So-
okay, yep.
Yeah, but it's pronounced Rowbottom.
Yeah.
So in this book, which is also a stupid name, Zetetic Astronomy, he proposed that the Earth is not spherical, but it is in fact a flat disk centered at the North Pole and bounded by a wall of ice around the circumference, which we call Antarctica.
Okay, well that should be very easy to find then.
Well, it's easy to find, but it's not easy to get past. So you can get to the edge of it, but then you can't go past Antarctica because it's a wall of ice. And if you get close, the government's there and they stop you from going any further. Sorry, NASA's there and they stop you from going any further.
Right.
Sorry, the United Nations are there and they stop you from going... An organisation is there and they stop you from going any further.
Well, I mean, that's should also be easy to find. So you just get to Antarctica and then just keep going until someone stops you, right? That'd be easy to find. You'd either see the big wall of ice. Someone must have evidence of this. If that's what it is, someone would have been.
No,
stopped.
they've covered up the evidence, Levi. They've covered up the evidence.
Okay.
Yep. So anyway, Rowbottom, he used the pseudonym Parallax because I guess he thought that sounded cool.
Well, it does, to be fair.
It does, kind of, yeah, and really, it kind of does, yeah. Anyway, he called his model the Zetetic method, Zetic, Zetetic method, or Zetetic astronomy. I don't actually know what that means. Basically, it's a pseudoscientific alternative to scientific astronomy and astrophysics.
Okay.
The major problem with Zetetic astronomy is that it does not produce a single unified model that both explains all of the phenomena we see on Earth, like seasons, night and day, tropical ecosystems, all that sort of stuff, and also accurately predicts events like eclipses, year lengths, weather events, anything like that. As an example...
Which is, sorry to cut you off, but this is the first
right.
problem with it, is that our current model of the Earth explains all of that.
Yes.
Very well.
Exactly. Yes, very well. Infallibly, one might say.
Yeah, demonstrably.
So as an example, when a flat earther's asked to produce their model for night and day, they'll usually show a flat disk, like imagine just a flat circle, with a line through the centre. On one side it's dark, and on one side it's light. And on the dark side, relatively small and close to the Earth, is the moon up high. And on the light side, relatively small and close to the Earth, is the sun, which is about the same size as the moon and the same distance from Earth, as in it's not very far.
Right.
So small and close, basically, instead of very, very big and very, very far away.
Mm-hmm.
There are two major issues with this model. The first is that it can't explain why the sun's light only travels a certain distance to the middle of the Earth, but then has to travel a lot further to get to the outside reaches of Antarctica. So if you think like, if the sun's in the middle of this half of the circle, you know, from the very middle of the circle, it only has to travel like a very short distance, but then to get to the outer reaches, it has to travel almost 3 times that that distance.
Mm-hmm.
But why? Why does it travel further in one direction and not in the other?
Do you mean, well, it's further away?
No, it's not. This is a straight line so half of the world is in darkness, half of the world is in light. The sun is on one side, the moon is on the other side, and the light comes out of the sun in all directions, right?
Mm-hmm.
And so it has to go all the way to like the edge of the circle at its longest point, and then it's at its shortest point, it only has to go right to the middle of the circle.
Oh, because that's where dark is.
Yeah, and then darkness starts.
Right. What stops the light from travelling?
Well, yes, that's a good question.
We know that light just travels and travels, unless it's impeded.
Well, then you have to assume that there's something that's stopping the light from travelling. But then there's no explanation given for what makes the light stop travelling. So that's the first major issue.
Mm-hmm.
The second issue, and probably the most egregious, is that the model can't account for seasons at all.
Nope.
So in order to do this, they say that the sun travels closer to the centre of the disk in June, but then it slowly moves out towards the edge as it gets closer to December, and then it heads back towards the centre as it gets, January, February, March, April, May, June, and then it's back to the centre in June. But if that was the case, you would need further explanation of why the light travels so much further across the disk in December than it does in June.
What do they think the sun is? It can't be a planet. What do they think that it is? What's making it move?
I mean, this is why I was so worried about doing it. Not worried. It's just why I was apprehensive about doing this topic, is because there are so many questions that these models raise that don't have answers.
And why is the sun round on all of their models?
Why is the moon round? We can see the sun and the moon at the same time sometimes? So how would that work if they're on opposite sides of the world?
See, I've heard a couple of different versions of flat Earth. One is just that the Earth is actually not round; it's just flat. But the other is, but it's still a celestial body. The other is that it's essentially a man-made object
simulation thing
inside a giant dome. Inside a dome.
Yeah, I heard that too. It's a like a Matrix level simulation of life.
But more like the Truman Show.
Yeah, it really depends on which flat earther you talk to as to which one they believe.
Yeah.
Anyway, if we go back to the main model that they use, and let's just take the second model of the seasons, right?
Mm-hmm.
So the sun is closer to the center of the disk in June, and assume that it somehow can put out different amounts of light for the different times of the year, right?
Mm-hmm.
So if you look at the path of the sun moving close to the center, that's quite a small circumference, right? It's quite a small orbit, I guess, around the middle. And then right out towards the edges, it's quite a large circumference. So like comparatively, there's a huge difference. So if the sun moves at a consistent speed, then an American summer in June would have to be significantly shorter than the winter in December, because if the sun travels at a consistent speed, it would take a lot longer to get around the outside circle, right?
Right.
But we don't observe that. The seasons are the same length as each other.
Yeah.
So, but then if you explain that away by saying that the sun actually moves at different speeds for some reason, for different seasons, then we would be able to observe the sun moving more quickly through the sky during winter than it does in summer. Because it would have to, it would have to go quicker in winter to get around that big circle than it would in summer.
Yep.
But we don't see it moving any quicker in winter than it does in summer. So basically, not only are the two main models that they use incompatible with observations that a child can make, but they're also incompatible with each other. There is actually a single model that explains both the difference in seasons and night and day, and that's the globe Earth model that we all know.
This is what infuriates me so much, is that this model, this belief that the Earth is a globe, it's not even a belief. It's a fact. We know it. It's infallible. It's just been around for so long, and it's demonstrable, and it explains just about everything on the Earth. Our seasons, our length of day, magnetism, and for some reason, flat earthers have disregarded that and have come up with their own theory that doesn't work in the slightest.
Yeah. So the thing that they latch onto, and I addressed this in our episode on the scientific method, and if you haven't listened to that, I would suggest that you go and listen to that, because that's basically an illustration of how we know the things that we know about science. But as I mentioned in that episode, there's no absolute way to say for sure that the Earth is a globe. Go on, give me some evidence that the Earth is irrefutably a globe.
I suppose the only way that I could do it is get into a spaceship and fly very, very fast around the globe, around the Earth, and in all directions, and then I could observe that it is in fact a globe.
Yeah, but you would have been a shill paid by the government to tell me that.
Yeah, that's right.
Did you take photos of it?
So you're not talking about a way to prove it to myself to know for sure. You're talking about a way
you have
that
to prove
I
it to
can
everybody.
Prove it to everyone. Yeah, okay.
So you might have taken photos, but I bet they were doctored by NASA.
Yeah.
Isn't it interesting how NASA is the only one who has photos of the world, apart from all of the other space agencies who are in cahoots with NASA?
What an assumption to make.
Well, that's just how it is, Levi. Like, honestly, any piece of evidence that you give that the Earth is definitely demonstrably a globe, it can just be refuted by saying, nah, no, it's not. That's propaganda. Like, given the evidence that we've accumulated over the last several thousand years, the globe Earth is pretty damn close enough to a scientific certainty as we're ever going to get.
So most conspiracy theories assign a motive to what they deem to be the truth. What is the motive of hiding a globe Earth? A flat Earth, rather.
That's the thing, though. Like, the real kicker for any major conspiracy theory is give us detail. What possible motive would all of the world's governments and scientific organizations have to lie so consistently over so long?
Yeah.
And there isn't an answer. There just isn't an answer for that. If you have enough level of distrust in experts, governments, society, evidence, science as a concept, how on earth will you ever know what to believe?
Mm-hmm.
The resurgence of the belief in a flat Earth in recent years represents an absolute failure of logic and critical thinking. Ultimately, a failure in education. In the end, if we're just talking about comparing the two models of a flat Earth versus a globe Earth, on one hand, you have a complete single model developed by legitimate scientists over centuries that is coherent, unified, predictive, while on the other hand, you have many disunified models which are neither predictive nor empirically verified, which require endless assumptions about everything from moon landing denial to anti-vaccination. They're peddled by basketball players and hilariously underqualified YouTubers. It's egregious to even compare them, and now that we have, I would like to apologise for doing so, and we won't do it again. Flat Earth is ridiculous. That's all I have to say about that.
Nice rant. I suppose one way that you could have approached the topic of flat Earth is look at videos of flat earthers putting their point across about why the Earth is not a globe and why it's flat, and then refute each point. But you'd be there forever, because
I would be. There's an answer for everything.
Exactly. They have an answer. And as you've said, every answer that I give that is proved by science has been come up with by using falsified information provided by NASA or some other space organization. You can't argue with these people, and I suppose it's probably better off to just say a globe Earth is so infallible, and I can't believe that anybody actually believes that the Earth could be flat, and it's really not worth all that much of our time, to be honest.
No, that's probably why I've been apprehensive to do this topic, is because I don't even know where to start or where to end. Do you know what I mean? Once I start, I want to address every single point that they make, but then that's pointless because everything that I say, they're just going to say, "Nah, you've just used your scientism and you've been indoctrinated from birth," and blah, blah, blah. So there's just nothing to say.
I think you could probably actually have a YouTube channel, and I'm sure they exist, where it's entirely devoted to arguing with the arguments of flat earthers.
Right.
And proving them
They
wrong.
exist, believe me.
Yeah, right. Well,
I've spent the last couple of days researching all of them.
Yeah, it doesn't surprise me at all. I think what frustrates me a lot is the anecdotes that these guys use. And we've talked about anecdotal evidence before with people like Joe Rogan, who say these statements with such conviction and then don't back them up at all. Like there's a documentary on Netflix about flat earthers called Behind the Curve.
Such a good name.
Yeah.
It's so clever.
It's infuriating to watch.
Oh yeah, but the whole documentary basically is set up as a proof that flat Earth is a ridiculous theory. Like the whole thing is about this big experiment to end all experiments about how it's going to show that the Earth is flat once and for all. And at the end of it, they do the experiment and he goes, well, the only way that this could be the case is if the Earth is a globe. And then it kind of realizes what he said and he's like, oh, wait a minute. that can't be right. What?
Yeah. But I just hate that there's this statement that one of these guys makes, and he's standing at his house and he looks over at, I think it's Philadelphia, and he says, given how far away Philadelphia is, if the Earth was a globe, I shouldn't be able to see the city, but I can. That proves that it's flat. So they're using just such awful logic, and that's untrue. You should be able to see Philadelphia from where he was standing.
That is untrue. The thing is that somebody has used maths at some stage they call that the 8 inches per mile squared is the equation that they've come up with. It's the equation of a parabola. And so it is a thing that they use that is based on mathematics, but it's the equation of a parabola and not the curve of a sphere. So okay. There is a formula for the curve of the sphere, and it's not 8 inches per mile squared, which just doesn't make sense when you're talking about a sphere. It makes sense when you're talking about a parabola theoretically.
Yeah.
But so what's happened is someone's performed some faulty assumptions about the shape of the globe. They've done some mathematics from high school that is not reflective of reality, and then all of the flat Earth people have taken that and gone, well, look, I can see Philadelphia, so the Earth's flat. It's like, well, you've started from a faulty assumption that the Earth is shaped like a parabola.
Yeah.
And it's definitely not shaped like a parabola. Do it with the actual mathematics, and it's reflective of reality. Yeah. That the Earth is a globe.
I know.
So, but all they see is, oh, some guy's done the legwork on this. I'm just going to take that and run with it, which is exactly how science works. Except the people who do the stuff in the first place actually know what they're doing.
What about when you're sitting at the beach and you watch a boat leave the shore and disappear over the horizon? Yeah, even with honestly, the best telescope, you would not ever be able to see that boat.
Not once it goes far enough.
That's what I mean. Yeah.
There's no explanation for it. Honestly, I don't know how else to refute their arguments.
Yeah, I've got to stop bringing up examples because
we're gonna go forever.
It frustrates me so much.
Yeah. No, I totally get you, and I just don't. I don't know what else to say. It's frankly ridiculous that people in the modern world believe. It's so much more like not believing that we landed on the moon is one thing.
Yeah.
Not believing that the Earth is round is just... I honestly can't believe that people believe that.
Because the fact that the Earth is a globe is so fundamental to everything that we experience.
Every single thing. Everything. Honestly, there is very little in the world that doesn't have anything to do with the world being round.
Yeah.
Weather. Like, you walk outside, the sun's shining. Sunset. How do you explain sunset if you're on a flat Earth?
Yeah.
It's frustrating. Anyway, I think we've ranted about it enough. So
Yeah. Too much. I'm going to be mad for weeks now. I try to avoid it at all costs.
Well, you're the one who suggested it. So.
And here I am in the belly of the beast.
That's it for this infuriating episode of Idio Facto. Forward all suggestions, hate mail, evidence for a flat earth, don't bother, and arguments to idiofacto@gmail.com.
And you can reach us on Facebook, Instagram, Twitter, and all other platforms at Idio Facto. And the links are in the show notes.
And don't drink disinfectant, it won't help with COVID-19.
And don't inject it into your veins. And don't expose your body to UV light in an attempt to kill the virus.
No. Or under your skin. Don't do that either.
And don't listen to any health advice from any of our world leaders that's not also endorsed by the World Health Organization. The Latin tectonica, meaning pertaining to building.
Oh, I thought it was, isn't it Encyclopedia Tectonica? Wasn't that a CD-ROM encyclopedia that people used to use?
Actually, you know what? You're right. Yeah, I think that's what...
Related to Encyclopedia Britannica.
Yeah, I think that's what tectonic plates were named after.
Yeah, That's what I thought.
Well, we haven't always known...
Very silly. Sorry, very silly.
Very silly. Shh.
Okay. Sorry.